Assalamu alaikum, dear students. After a long time, we are back to our recording session. So, in today's lecture, we shall talk about nucleophilic substitution reactions of alkyl halides. So, the substrate in nucleophilic substitution reaction is an alkyl halide. As we know, the electronegativity difference of alkyl and halide, mostly the halogens are most electronegative elements. So, the shared pair of electron will be more towards halogen, and therefore, there will be a partial negative charge on halogen part, and there will be a partial positive charge on alkyl group. So, this bond is polar in nature. So, this polarity is the basic root cause or reason for their high reactivity towards any nucleophile. So, nucleophile is any species which is carrying a lone pair of electron or carrying a negative charge. So, this negative charge or lone pairing carrying species is attracted towards positive center of this bond, and there is a heterolytic cleavage of bond between halogen and alkyl group. So, there is a large variety of nucleophiles which can attack on any alkyl halide. So, here we have a variety 1, 2, 3, 4 and 5 nucleophilic substitution nucleophilic species which can react on alkyl halide. So, usually these nucleophiles are in the form of their metallic salts. So, if we connect here a metal, so this will become a complete salt. So, now I am going to write their salted form, and in most cases the metal here is sodium, lithium, sodium and potassium. So, this is a potassium, lithium or sodium alkoxide. This is sodium, potassium or lithium carboxylate, and this is sodium, potassium or lithium thiol. Likewise, this is a cyanide and this is a azide. So, this nucleophilic part is usually in the form of salt, and this is organic molecule. Both of these two substrates have different type of nature. Usually the salts are soluble in water, and organic molecules are soluble in polar solvents. So, to conduct reaction of these kind of species, we need a special kind of solvent system to make a proper homogeneous reaction mixture. So, usually the solvent system used for these kind of reactions is, I am going to write here heading for solvent system. The solvent system is usually a combination of water plus alcohol, or DMSO is a solvent which can solubilize both of these two species, salt as well as alkyl halides. So, when these two species go into solution form, so in the solution these species will be in the form of their negative charge. So, I am going to erase this metallic part, because now we are going to discuss their reaction. So, when these species will ionize, there will be a negative charge on this RO negative group, there will be a negative charge on carboxylate ion, there will be a negative charge on this thiol group, negative charge on cyanide and negative charge on this azide group. So, this negatively charged oxygen can attack on this partial positive part of alkyl halide, there will be a homolytic cleavage of Rx bond. Similarly, this negative charge of oxygen will attack on this partial positive carbon, and there will be homolytic cleavage of Rx bond. Likewise, this reaction will happen in the same pattern. In this case, similar kind of reaction will take place, and in the last case similar nature of homolytic cleavage will happen between R and X. So, what will happen? R will establish a new bond with this oxygen. So, I am going to write here ROR. The indication of color combination is very much clear that this R is coming from alkyl halide, and black color is indicating that this bond pair oxygen and R is coming from this nucleophile. Next one is ROC double bond OR. Here will be R SH, here will be R CN, and in this case will be RN3. So this class, as all of you are very much familiar, this class is called as ether. This is ester. These are called as thiols. This is called as cyanide, and this class is called as azides. So uh, from these reactions, we can clearly understand thus the alkyl halide are precursors or sources to develop or synthesize a large class of functionalities in organic synthesis. So it means we can prepare ethers, we can prepare esters, we can prepare thiols, we can prepare cyanides, and we can prepare azides from alkyl halides. So from this we can conclude that alkyl halides are too much useful in synthetic chemistry. Now the question arises that what is the source of alkyl halide? How can we prepare alkyl halides? So the answer is very simple. In previous classes you have studied halogenation of alkanes, that is in the presence of UV radiation. Subsequently, one of halogen is replaced by halogen. So it means the first route by which we can prepare alkyl halide is halogenation of alkanes. The second important route for the preparation of alkyl halides is hydrohalogenation of alkenes. CH2 double bond CH2 plus HX. So halogen and hydrogen, this will add to this alkene and we will get alkyl halide. And the third important route to prepare alkyl halide is nucleophilic substitution of alcohols. If we have any alcohol, for example, I am taking methanol and here is any halogen atom connected to a positive part, so we can obtain methyl chloride. So alkyl halides are very much important precursor in organic synthesis, as we have already studied that we can prepare at least 5 functional groups from these substrates. Now we are going to talk about the reactivity of alkyl halides. So the first, we can start from alkyl fluoride, alkyl chloride, alkyl bromide, and alkyl halide. So which one of these alkyl halides is most reactive? So the most reactive alkyl halide is alkyl iodide, then alkyl bromide, then alkyl chloride, and least reactive is alkyl fluoride. Why alkyl fluorides are least reactive and alkyl halides are most reactive? The reason behind this is that the size of carbon and fluorine is comparable. Both of these two elements belong to similar period. So when there is a bonding between atoms of similar group or same group, so the bonding or overlap of orbital is stronger. So in this case, iodine belongs to the bottom of of a group. So the size of iodine is very much larger as compared to carbon. So this bond is weaker bond. So this bond can be easily ruptured and we can obtain R positive and iodide negative. Another factor that is involved to determine the reactivity after breakage of bond, the species which are produced should also be stabilized. R positive and F negative. Here will be R positive and iodide negative. So you are familiar with the concept of polarizability or distribution of charge. So when there is a larger size atom, the charge distribution of negative will be dispersed to this whole atom. As compared to iodide, fluoride is a smaller size atom, so the charge on this smaller size atom will be concentrated. So whenever either positive or negative charge is distributed between different atoms or on a single atom, the effect of charge is decreased. So we conclude that alkyl iodides are most reactive. They are many times reactive as compared to alkyl bromides, and they are 50 to 100 times more reactive as compared to alkyl chlorides and alkyl fluorides. Thank you so much.